Here we go. There's a question about the quantum model of light, i.e. the idea of photons. As ever, please have a look, and when you're ready to see an explanation, hit play to see if you agree with me. Okay, I think this is a really nice question because it kind of tests your understanding of how the particle model of light works. Put simply, when we're looking at light, we are interested in it as being made of photons, and the intensity of that light is going to be made up of two things. It's going to be made up of the number of photons per unit time and also the energy of each of those photons, and that's what's being investigated here. What I'm going to say is that the intensity of light is equal to some constant times the number of particles, number of photons per unit time, and multiplied by the energy of each of those photons. So this E here is the energy of each individual photon. N is basically the number of photons per unit time. The K is just a constant. Don't worry about that too much just now. If we change those numbers, then it's going to be the same. However, our constant remains the same. Now, if we take the case firstly where we're going to double the wavelength, we first have to think about our relationship. The energy is determined by the frequency and therefore is determined by the wavelength. If we double the wavelength, then we have the energy of each of those particles. So E has gone to E over 2. We also know that we're going to double the number of photons per unit time, so N dash is equal to 2N. We're going to put those into our equation. We're going to find that actually those two factors of 2, one on the top, one on the bottom, are going to cancel each other. I'm kind of annoyed here, that should be a K. All right, KNE. And so in other words, I dash is equal to I, and therefore the intensity remains the same.